introduce to you. First, Daniel Klaus. He's the current CEO of Clear Data. He's a graduate of Duke University and UCLA MBA with 20 years of experience in data analytics. He's led analytics teams at Loan Depot, Arch Bay Capital, Experian, Genomic Health, and he's got a focus on analytics and data visualization. And he's our go-to guy for BI, especially specialty tools like Tableau, ThoughtSpot, and Automated Insight. Hi, Dan.
Hey, Dan. How are you?
Great. Thanks for joining us.
Thank you.
And today we're also, one of our presenters is going to be Ed Schaefer, is the Dell EMC's Healthcare Informatics Director for the Americas. Ed has 20 years of technology solution experience and is a big data expert, helping customers identify and understand where and how they can exploit data. Ed was the Big Data and Cloud Global Portfolio Manager for Dell Technologies, and his resume includes Big Data Senior Solution Principal for North America across several verticals, including healthcare and life sciences. He's also been with IBM Global Services and is a regular contributor and speaker at HIMSS. So thanks for joining us today, Ed.
Dan, thanks for the invite. Happy to be here.
Yeah, we're very lucky to have these two guys because they're two of the guys I think of as the thought leaders in kind of the big data spot. And I invited them, and they said yes. So I'm happy that they could join us. And thank you guys for joining us on the webinar today, the attendees. As you know, our webinars are usually monthly. We try to do at least one a month, and they're really focused on kind of delivering one whole unit of education. That's how I like to say it to the attendees. So welcome your feedback as always. But today we're going to cover an introduction to how to get more enterprise value out of your data and what big data is. You might have heard that term before. We're going to find out what that is today. And how is it different from traditional BI? And we'll look at some case studies with Lawson data, and then we'll kind of cover how you would get started on your journey for big data. So without any further ado, guys, what is big data?
Yeah, well, I think if you look historically, this term has migrated quite a bit, but the first kind of official reference dates back to 1997 when some NASA scientists were sort of talking about this problem of, essentially how much data can you keep in memory? In other words, you're looking at a single report or kind of analytical tool, and there's only so much memory you can kind of manage to look at one time. And so that kind of was the beginning of this term big data, meaning it's too big to do something in memory. You have to kind of store it and do.
You can't just run queries on it.
Yeah, exactly.
Right.
You have to. It sort of changes the whole game, and so, it then sort of took hold incrementally in places like Facebook and Google, where they have massive collections of data, and those guys really started to innovate into what is now kind of called a data lake, or a sort of a Hadoop style storage, where you take and in highly parallelized, storage systems, you can actually do query-like operations on the data. And so that really became kind of the original, now it's like a real thing. It's, mid 2000s now maybe, and we're talking about big data is becoming kind of a known quantity. What's happened from there is that it was never really, that's really just kind of talking about plumbing and storage and putting data in place and using it. Where it's really migrated to now, what people talk about big data now is how do you harness all this to do useful things and to do smarter, more analytically driven things. And so the term has actually kind of gone, in a bit of a broader direction. But, for our purposes here and just in my, everyday, professional life, I think of big data as, it's basically this all-encompassing term that talks about how do we take large, small, whatever sized amount of data and actually do useful things with it and do, kind of more analytically driven or data science oriented operations to get more value for the business.
Yeah, it's a good answer, Dan. I'd only add to that some people probably have heard of the 3 V's or the 3 V's and a C, which is basically volume, variety, velocity, and complexity. And typically the data that we used to look at and analyze was predominantly structured data, things that you could find in a file. And now data is semi and also unstructured. If you think about like a video feed or a weblog. And so being able to analyze these things all together became too difficult the way the old technology performed. And if you could think of an example of leaving your house and going to your car and realizing that you didn't have your car keys. And if you were trying to like retrace your steps, if you were using the old file query model where you basically had to look in every part of your home, you know, you might look in the living room, the kitchen, the bathroom, the bedroom, and then eventually you find in the closet and the hamper is your keys in a pocket of jeans. Well, the reason that big data and analytical querying is different now is that you're able to add compute to it and you're able to look at things in a parallel fashion. So imagine that same scenario. You would now be able to look for your keys where you're essentially having somebody look in the kitchen while somebody else is looking in the bedroom, while somebody else is looking in the bathroom and in the closet, and they're only looking for keys, nothing else. So when you did the old system, you would look a query or you'd have a query, it would have to look through everything that's in that folder and every part that folders are stored in your system. And sometimes queries wouldn't complete because it just took too long to run that query. Now, as soon as you start typing a few letters in Google, you can see it's already predicting what you're, about to complete that sentence of. And so when you add compute, you're actually adding power and speed to search for that query. So it just kind of gives you some additional thought around big data.
Got it. All right, here we go.
So basically, to kind of describe big data and where we are and where we're headed, it's amazing how much data that is upon us. And by Forbes put out this study that by 2025 we're expected to have 163 zettabytes of data per year, and we'll have about 8 billion people connected on the planet. And they'll have 75 billion devices and they'll be interacting with those devices every 18 seconds. And what's crazy is that they're saying that up to 20% of that new data that's being generated is going to be critical to our well-being.
Yeah, I looked up that term zettabytes, and it's a one with 21 zeros in front of it. It's a pretty impressive number. I hadn't heard that before.
We're seeing data in a lot of industries, and given my background in healthcare life sciences, we see some common themes where big data is being applied. And I in part of my analysis and research, had pulled together big data experts across the country, took surveys of interviewed customers that were pulled together in reports from some strategy consultants. And what we're seeing is so there's typically right now about 8 themes that are very common as it relates to big data. And cybersecurity is the first one. And surprisingly, in 2018, cyber attacks have doubled within hospitals. And by 2020, they're expected to quadruple. So basically, they're seeing that it's very porous in the healthcare space. And those systems need to obviously be better secured. So we're looking at ways for big data to help there. Mobility and cloud, everybody has a smartphone pretty much now and typically is accessing information through some sort of cloud service. So we're definitely see that spill over into the healthcare space as well. Telemedicine is very common, especially in communities where access to care is centralized. So we're seeing the ability for us to be able to leverage data and tools to have interactions in a healthcare setting that are beyond the typical 4 walls of a health system or hospital. And wearables are becoming increasingly popular as we have Fitbits and Apple Watches that are capturing some of our activity, and some of our biometric information is able to be shared. And artificial intelligence is a really promising area within healthcare and life sciences because we're actually seeing a lot of physician and nurse fatigue. And a lot of that is because they're spending so much time trying to get access to information, and we have the ability to leverage the computers and the querying to be done in parallel, so we can have our practitioners spending more time in front of a patient, being informed by the information as opposed to having to kind of do all that research on their own. Blockchain is a term that's been popularized by Bitcoin, but Bitcoin and other industries are essentially using this global GL, where you've got this grid of transactions that come and go. And in healthcare life sciences, we're seeing that predominate around two use cases. The first is really around how we stymie security attacks. So you can basically see what type of activity and what type of inbound packets of information are coming into the infrastructure, and we're able to basically, manage and mitigate some of that cyber terrorism through blockchain. And we're also seeing it in how we're emerging from a cloud perspective around the electronic health record, whereby in the next few years, imagine we're going to have the ability to completely control our electronic health information, and by virtue of some of the other wearables and stuff that we're capturing that's non-clinical data, we'll be able to share that with our provider or with whomever we choose, but leveraging blockchain to do that, so we can kind of control who has access to it and at what point of time. Internet of Things, or Internet of Everything, or kind of buzzwords that we've talked about, which is essentially almost every device out there has sensor and has compute on it. And the ability for us to capture information and even do analytics at the edge of that device helps basically continue to support this need for us to be able to analyze and drive insights from that analysis. And then again, machine learning is allowing the technology to support things that we're doing as humans. And that's also, seeing opportunities within the healthcare life science landscape.
And one really interesting use case of machine learning is actually, if you look at these newer deep learning algorithms where you're able to do things like computer vision, and some places have radiology or sort of image-based analysis that has to be done by humans, and you're now able to get a little bit of a boost from an algorithmic kind of approach to finding, an outlier sort of spot on an image or something like that.
Yeah, that's a good point.
Yeah.
So, we've got a lot of our customers and Lawson, essentially clients on the webinar here, and in the future, I'm sure that's the audience that's going to be watching this. And I think for the most part, they're very familiar with the term BI. That's really kind of how we go in the Lawson world about analyzing our data and answering questions that we have. So how is big data different from traditional BI in your eyes?
Yeah, it's a very good question. Next couple slides, I think we can kind of differentiate the value. Business intelligence originated around the data warehouse, where we basically built out an environment so that we could pull in data, transform it, and load it into a view where we could do analysis. But that required us to know the data that we were going to look at, and it remanded us to just structured data. And it also required us to know or conform, to what the question is that we're asking of the data. And with big data, it's not like that at all. So you want to pull up the next slide here. We can kind of talk through that. Oh yeah, so it's a little bit of a busy slide, so bear with me. But essentially, we've got basically a vertical and a horizontal axis, and essentially in the realm of business intelligence, there's a lot of effort to curate data and parse the data that you want to look at. And say in the healthcare, you're typically looking at, maybe you might be wanting to know how many patients did you have last month and what was their average length of stay, what percentage of the patients were covered by Medicare, what were the most important DRG codes to our business last month. If you were looking at those questions, and those were things that were standard questions that you needed to report on, you would refresh your view, and a BI report could be generated to provide that. That's great, and it does provide some level of value to the business, but it is an expensive technology platform to support, and it takes a significant amount of effort to curate that information. Now, when you're doing data science work where big data comes in, you're basically not doing anything about parsing the data up front. You're basically trying to get a view into all the data that you can, and then allowing what's going on within the data set to formulate your questions. So in the healthcare setting, you might say, is there a correlation between gender and length of stay in the hospital? Or, hey, we had a significant uptick in hospital-acquired infections last month. What are the 3 or 4, most common denominators of that? Or based on the number of admissions that we had for DRG code X, how many do we expect to have next month? Or why are these trends happening? So those questions are formulated essentially based on what the data is suggesting you. And it's an unfiltered view of the data versus a parsed view from a business intelligence standpoint.
So it's kind of helping you ask the right questions rather than with BI, where traditionally, I'm asked, what was our attrition rate in Q1 of 2016, and I can go write that query and get it back. But like in this case, you're feeding it a bunch of data, and it tells you these are the right questions to ask. So it's a very different type of approach in that sense.
Yeah, exactly right. If you were looking at, how many employees did we lose last quarter, that's a report, right? But if you're trying to understand the causality of why you lost those employees last quarter, well, then that's a big data.
You wouldn't even know what questions to ask up front. Right. That makes sense.
Yeah. So in terms of how you architect the solution differently with BI versus sort of big data, one of the key differentiating factors is at what point do you create a schema? A schema is essentially you're making a choice about how you structure the data. You're making choices about how those different tables or entities of data relate to each other. And there's a lot of work that goes into that process, which is kind of why traditional data warehousing projects take a long time, because you have to kind of get really close with the business and understand their requirements. You kind of go through a traditional, start to finish type of project where you have a goal in mind, you have questions you want answered, you go and build all this structure and schema to answer those specific questions. And if you're good, you can kind of go a little bit beyond those questions with additional anticipation. But essentially, you set out on if this could be a 3 to 6 month project or even longer to build a really traditional data warehouse. And at the end of those 6 months, you can answer the questions you thought about 6 months ago. So it has its place. It's certainly, there's nothing wrong with it if you're kind of inside the box of like, well, I'm running an accounting department and I need to know profit, loss, expenses, and those questions are well defined. You don't need to be too clever, right?
Necessary part of the business.
So this is an essential thing. It's just not the more open-ended kind of, if you don't know what questions to ask, that's the
or in some cases, the question changes. Or now that I know this, now I want to ask a new question.
Right. So how's that different from the other model? Yeah.
So with this other model, we're talking more about a data lake, which is really just a data lake is kind of just a generalized term where we're going to gather all kinds of data together, structured, unstructured. This could be, data from the internet. You could have CSV files, text files, photos, anything, right? I mean, it's a much more broader and kind of expansive exercise, and you just sort of gather all this data together. And when you get into the business of asking questions, that's when you create the schema, the structure. So you say, okay, I have a bunch of images and I want to understand, like, if I'm monitoring a laboratory, what time do people come in and what time do they go out? And so you start to kind of like drill down into that question and create the schema you need to answer those questions. But because you have essentially the schema on demand or schema on query approach, you don't have to spend extensive effort in building those structures before you can actually answer the question. So it becomes a much faster exercise, a much more iterative and kind of question answer type of feel to a data science or kind of big data implementation.
Yeah, that's totally right. And so when you're comparing, how do you do analysis, the effort up front is required from a BI perspective, and the effort is then more on after the fact on the big data standpoint. But you basically need both in order to have a complete picture, and most have both. The storage requirements for big data are a lot less expensive. It's the storage requirements for data warehouse are a lot more cost prohibitive. So what ends up happening is you have people that are super users or have access to the data warehouse, whereas in a case of big data or a data lake, pretty much all the data is there, and you can avail access based on the types of querying or analysis that you're looking to do. So in order to kind of encapsulate this, let's kind of show the value of business intelligence and big data in action here. So this slide is essentially about a metropolitan area where we've got a report that shows both the number of events of traffic accidents where there's a fatality and the concentration or severity of those. And this is, say, over a 6-month period. This could be very easily built into what would be a BI report, where we are asking a very specific question of the data set, and we're looking at the output of that data set from that, which has value. From moving forward to now that I know what happened over the last 6 months, and we go, well, how does that impact what's likely or what could happen over the next 2 weeks? We start to make hypotheses. And this would be something that we're doing that could be both a BI extended exercise, or we start kind of getting more into the big data, where we're really trying to make an educated guess based on what we know. The next slide then is taking that one step further, and it's saying, okay, based on what we know, we're going to anticipate that this is what's likely to happen next. And if we knew this, then how might we inform our first responders so that they'll be ready in case our hypothesis turns out to be accurate? So this very specific slide is talking about how we would stage our first responders based on the predictive model that on the previous slide. Then taking that one step forward, over time, we iterate on that information and start to smooth out how the first responders should be staged, and eventually how to mitigate the traffic patterns based on the historical view, so that ideally we reduce fatalities and traffic-related accidents altogether. And that's where you can see how there's a differentiation between the value of BI, which tells you something about what happened, and incorporating big data to it, which then allows you to improve outcomes as you go forward.
Yeah. So as you know, most of our audience is a Lawson customer base, and a lot of healthcare, a lot of education, a lot of retail, and gaming, insurance, all sorts of different customers. But the data they're dealing with is essentially the data that enables you to run the back office of your business. So we're talking HR payroll data, benefits data, or accounts payable data, and general ledger and whatnot, or procurement data, that sort of thing. So can you give us some of the case studies that you've employed this technology on Lawson data to answer or create questions that weren't there before, or answer questions that weren't necessarily they're obvious?
Yeah. So given the fact that big data is basically horizontally valuable, meaning it's not tied to a specific industry. One of the common misconceptions that a lot of customers will ask when thinking about how to leverage data differently is they want to know what a customer in their industry is actually doing. So just take for example, if you are a retail customer and you sell apparel, the typical customer question might be, well, hey, so and so is your customer. How are they leveraging data for their business? Maybe we should do something similar so that we can get some economies of scale, or we can make improvements to our business. When in actuality, the way big data is best leveraged is actually not looking inside out, but looking outside in. If you look at Tesla, for example, when Tesla was designing the chassis for its vehicle, they didn't hire like Ford and GM executives to try to basically replicate the success with inside the car industry. They actually hired software developers that could apply software development in a very agile environment and apply that best practice into the automotive industry. And as a result, what the Tesla has created, for example, there was an issue where they had a recall with respect to part of the mechanics of the vehicle. And with the mere software upgrade, they were able to fix all of those cars without having to physically recall those vehicles. Had they approached that problem the way a typical automotive executive might, they would have been, trying to solve that problem the same way. Another example is when you go to an airport, everything from when you get dropped off until you board the plane are kind of considered micro events. If you go to a hotel, it's the same thing. If you go to a casino, it's the same experience. If you download software or games at a website, or if you're buying products online on Amazon, all of those are micro events. And if you were to look at best practices across all of those industries and if you're looking at how to improve the consumer experience, you could learn just as much, from if you're at an airport on how like a hotel company might optimize the consumer experience and model that at an airport, just like if you're trying to download software and you're trying to replicate that same experience as if you were trying to buy on Amazon. So again, we try to look outside the industry for best practices on how big data can be exploited. Now, with that in mind, a really good example of how within, say, healthcare, we had a Midwest provider that was about a $4 billion company, operated in 3 states, and we were interested to see how data could improve some of the quality measures that was concerning to them. And they were dealing with some things like an unusually high level of attrition from an employee turnover standpoint. And were essentially asking us how we could look at data differently to improve their business. And of course, their first question was, well, how do some of your other customers in health system, how do they approach the problem? And we said, well, look, let's not worry about what others like you are doing. Let's worry about what kind of data we can get access to, and let's analyze that data and see what we can come up with. Well, anybody who's in the healthcare space understands that the EMRs, the Epics, the McKessons, and Cerners of the world, they typically are not willing to share a lot of information. And so we were encumbered to try to do some analysis without having the Epic data at our disposal. So we said, what can you get us? And they gave us some Lawson data, and we looked at some ER admission data, and we also looked at some time and attendance data. And we, in viewing that information in an aggregated view, we actually looked and surmised that we thought, just like that traffic incident, that based on history and overlaying that with some weather data and some regional demographic information, and looking at the seasonality of the emergency room, we could predict based on pulling together different data sets what the ER admissions would likely be, and furthermore, what the DRG codes associated with those visits might be focused around or concentrated around. And if we knew that, we felt like we could improve quality of care, impact length of stay, without impacting the cost of care, or in a perfect world, actually reduce the cost of care. And so what we were able to do in that instance is effectively look at the employee information that were comprised to provide care to these patients. And we had access to some knee surgery patients and some hip surgery patients. And we basically we kind of analyzed their patient flow through a hospital setting. And essentially what was interesting about the Lawson data is that we learned that there were certain DRG codes or ICD-10 codes associated with certain conditions that not every doctor or tech or nurse were optimized for. So, maybe Tan and I are really good when it comes to flu season, but maybe Tan and Dan are actually, better working together when, there's a knee operation.
So from like a staffing perspective. Yeah,
Right.
Right.
So we realized that if we looked at who was the optimal staffing mix for knee surgeries, and we know that there's a stronger likelihood of having a knee surgery, or we've got more knee surgeries planned, then we should have that staffing mix, to provide care. Because anytime you can be more efficient and have a more successful, surgery, that's better for the patient. And if you work well with others better, then you're going to, actually improve employee satisfaction. You're going to reduce employee attrition. And so we found very quickly, just by optimizing the staffing mix based on the information that we gathered from Lawson, we were actually able to reduce their 18% attrition rate down to more of the industry standard of 12%.
So that's pretty incredible. I mean, you took data that had nothing to do with anything. I mean, I couldn't imagine what like hip and knee surgery related data has to do with my employee attrition rate, because it just doesn't make any sense to us as human beings to look at data that way. But you feed all this data into a machine, and it basically tells you, well, it looks like if you do your scheduling slightly differently, so people are happier with the job that they're doing and they do it better, they're more likely to stay longer. It's a very counterintuitive point. So,
and what's interesting is when we first tried to interview HR to get access to the Lawson data, they're like, look, we've got our own problems here, and helping you figure out who's going to come into the ER doesn't really pertain to us. But the aha moment for them was, anytime you analyze data in one area, there's actually intrinsic value to other parts of the organization. So it's almost as if you can start anywhere you want and look at any kind of data that you have access to, and it'll tell you something. Now, some of it, is going to be more valuable to you than others, but that's what the data science process. We'll talk a little bit about for later in this webinar. We'll talk a little bit about that. Another good example from a kind of a government or a case study standpoint is we had a government in Slovenia who had basically a perception problem. It's a very affordable part of the Eastern Union, and they are in a very beautiful climate, close to the Mediterranean Sea, but just we're struggling to pull top tier talent into the country from a professional standpoint. And because they're a European government, the employee rights were heavily protected, and they were trying to figure out how to stamp out some fraud and some waste and some productivity issues, because they couldn't just fire people because they didn't have anybody to replace them with. And, they also were trying to figure out how they could improve employee performance and satisfaction at the same time. And they were typically figuring out, how can we cut costs and improve productivity? And sometimes those sound like competing interests. Well, in that instance, we looked at the Lawson data and we aggregated that with, believe it or not, email traffic data. And in their case, their government gave us access to telephone data. So we were actually able to see when people were on their mobile devices, when they clocked out or logged out for a break, how many emails they sent out a day. And we could actually profile and map who were the bad actors in the organization. And it wasn't so much that these were bad employees, but maybe they were in roles that they were not suited well for, or maybe they needed to be challenged or needed to be, put into other roles. So we were able to do some text analytics and look at, type of sentiment that, these employees had. And we could say, hey, this is a person that's consistently taking 3 or 4 hours off a day. And subsequently, the government work is not getting done. And yet, instead of firing them and being punitive about it, we actually reached out and had put a pilot together to inquire on what inspires them and what they'd like to be doing, and then basically kind of morph them into those types of roles. And very quickly, within 3 months, they started to see these positive trends and the productivity increased. And when you have happy employees, you're going to have better outcomes. And this model was then presented by the Deputy Minister of Public Affairs to the whole EU, and it's now being replicated in other government settings, across Eastern Europe.
that is very interesting. That, again, data that seems seemingly irrelevant for the problem you're trying to solve. And I think that's really the whole point, right? That's like the theme of this thing is you just don't know what questions to ask because you're only seeing what's very visible to you.
Yep.
But there's a lot of invisible data that doesn't necessarily make sense on its surface. So how do we go about leveraging big data?
Yeah, it's a very good question. So we've got a slide here that is we have a slide here that's on the next slide that's basically the big data business model maturity index, and essentially it is measuring how successful an organization is at analyzing data. And in the bottom left of this, you'll see business monitoring. So when we were kind of looking at that multiple slide example of traffic, and you looked at what the fatalities and the numbers were over a 6-month period, that report would be a perfect example of business monitoring. I like to call it the 3 W's: what's happened, what's happening, and what will happen. And I would say that business monitoring kind of falls into that category. One step a little bit more evolved is being able to apply some of the information that you understand about the business and being able to do something with it. So in the case of that traffic example, it's like, all right, based on here's the hot spots in this metropolitan area where there's traffic accidents more frequently. Well, then, so let's do something about it, which in that case, it was about informing the first responders, where they should be positioned at certain times of day to be ready for those types of anticipated accidents. And then business optimization is one step even better, where you actually can automate things. So basically, if you've got certain types of limits or thresholds or things that fall so far out of a range that you can create alerts, and then those alerts can automatically create business process to essentially capitalize on those insights. And that's where you drive real, true business value. And again, in this case, this would be like as soon as we anticipate due to weather or due to some sort of significant event that we're going to have a negative impact to the traffic patterns. As soon as that trigger alert happens, then it automatically informs the first responders. So, and then one step further, we go to insights monetization, and that's being able to say, hey, we've noticed something about a population, or we've noticed something about a product or a process. And based on our insights derived from analyzing the data, we have something that we can share to the marketplace. And we see that very common in healthcare. We see that very common in the financial services industry. There's lots of opportunities to monetize data, and that's essentially what's happening here. And then ultimately, the holy grail is to be like, Facebook or Google or a lot of the other transformed companies where they know so much based on the data that it opens up brand new businesses for them.
So in cases I can see you, even in healthcare, you can come up with new products and services that you are conjuring up out of the data that you see. That's pretty interesting. So I guess being, on the one end of this, where you're barely using any of your data, and I'm sure some folks on the phone are probably even further left than what you're seeing on the graph here, and being on the rightmost side of this graph, or the upper right quadrant there, where your business is being led by your data. I wanted to do a quick poll of our audience to find out how does your organization leverage data analytics to run your business. So you should see a little poll pop up on your screen, and go ahead and rate how you feel your organization does from a data analytics standpoint. And I kind of have a feeling I know how this is going to go, but let's get we'll give these guys a few seconds here.
And rock stars, man.
Yeah, we're all the rock stars. Where are you?
We're the rock stars. Come on.
They don't have to show up for the webinar because everything's automated for them.
All right.
All right. So we're going to go ahead, and I'm going to close the poll now, and you should be able to see the results. All right. The results should have been posted to you guys, but let me see if I can see it. Okay, so we had 50% we can do better, and 36% was don't ask, which I imagine I know what that means. And there was a few mess, which is we probably don't care enough about it just yet, or we haven't
figured out how to
yeah.
exploit data yet. Yeah.
So thanks for entertaining us with that folks. So really, given that, if we wanted to do better, and if we wanted to care more about our data, how would we go about enabling Lawson and Big Data transformation? So how would I get from the left side of that graph to let's not shoot for the very top. How do we get to the next step?
Yeah, so it really it usually begins and there's some common sort of landmarks for any project you'd undertake to enable this. The first step is really just gathering together all of your data, ingesting it, putting it into systems that allow you to then go and ask questions and write queries against it. So, if you have a Lawson data source, or you have EMR, Kronos, anything that you think holds some potential promise, ingesting that into a data lake type system is really kind of the first two steps. One essential ingredient to this, which is really hard for most organizations, is to deal with this issue of metadata, the data that talks about the data. What is this Kronos system telling me? Like, what are the key metrics in there, and how do I define those? Mm-hmm. And making sure that as an organization, everyone's somewhat in agreement on what we're even talking about, because it's a very common kind of error that happens where, Ed thinks that, employee attrition means, people that left over a 6-week period, and you think it's a 6-month period.
It's more of a coming to terms and agreements on what these things mean, right?
So your numbers don't agree if you don't have that sort of essential metadata conversation. So the next step is really to kind of surface that information and enable people to share and explore and sort of do their own discovery against it. And that, really leads to some key insights that you want to exploit further. And so that's when you begin to think about big data analytics, data science, machine learning. You're applying more advanced tools and approaches to the data, creating models, creating predictions, sort of looking at the data through a more advanced, technology lens. And you can't do this with everything, so you kind of have to walk through it in this order. Like you can't do advanced machine learning algorithms on everything you have under the sun. You have to be more specific and more focused on business value. Mm-hmm. Say, okay, here's 10 ideas that I think could bear some fruit. Let's try to just skinny this down to like a few projects that we could go and reasonably expect to see some good results. And if you find some nuggets of gold in that exercise, create plans and policies and programs within your business to go and act on those insights, to kind of actually, exploit what you figured out, monetize the information.
So focus your effort, right?
Yeah. So this is a typical kind of end-to-end approach.
Okay, very good. And then, so I understand the approach, and then you've got a methodology for how you go about setting this in motion, right?
Mm-hmm. Yeah, we could spend a lot more time on this, but essentially, we've found that it's very effective if you can understand what the key business initiatives are for an organization, how they're being measured over the next 9 to 12 months. And based on that, what's the data and reports and other information that they're looking at that's imperative for them to analyze so that they can effectively accomplish their objectives against those key business initiatives. And so we basically try to get access to the data and reports and other information that supports that effort. We interview a group of departments to kind of understand what their challenges and what those goals are. We do some exploration of the data, and we enrich it with some of the other publicly available data, and that taking in that aggregated view and overlaying all of those different data sets together to try to understand what is the data suggesting to us. And then based on some context and iterative discussions with the customer, we formulate, okay, these anomalies are really nulls. We shouldn't pay attention to them. These anomalies seem alarming, and there's probably something here that we should investigate. And so we might look for some other data to support it and or to try to clarify what we're looking at. But ultimately, we reach a conclusion that the data has suggested something. And we get together as a group, those same leaders that we interviewed, we get together and we do an ideation workshop. And we literally say, hey, based on what the data is suggesting here, this invisible data that you described earlier, we think that there's some things that you can leverage. And given those key business initiatives, and maybe it's reducing attrition, or maybe it's reducing readmissions, or maybe it's like, how do we get 10% better profitability out of the sale of a manufacturing process for a product? Whatever those key business initiatives are, we can see how the data correlates to making that improvement or improving that outcome. And so then we crowdsource with that leadership group and say, okay, if we knew something about our patients, or if we knew something about our employees, what would we do with that information? And based on everyone's response, where anybody in the group has an equal vote, we will plot that out on a 2x2 matrix, which I'll show you the slide up next. And then we are going to essentially determine what the prioritized use case list looks like. And then from that, we make a recommendation on, as Dan was pointing out, kind of where to start. So if you go to the next slide, this is kind of what that looks like in a healthcare environment. So in this case, this was this Midwest healthcare provider that we had this opportunity to understand and predict what admissions would look like. And so we took the information and took Post-it notes from everybody that said, hey, here's something that we could do with it, and organized it by themes. And from that, we came up with a dozen or so themes. And then we said, all right, what's most important to you, given your collective business initiatives? And let's look about how feasible, like if we could cure cancer, that would be awesome. But that's probably going to take a lot of data, a lot of time, and a lot of resources, probably not, very reasonable. So anyway, so the point is to crowdsource and plot. And as you can see here, while everything was pretty important to the organization, not everything was as equally feasible, either because they didn't have the resources, they didn't have the time, or they didn't have access to the right data. But in this case, everybody felt like we could deal with unplanned readmissions. We feel like we could impact the hospital-acquired infections and conditions. And we figured that we could optimize service, and for all of those length of stays. So in this case, we were able to surface up a prioritized set of use cases where data could improve their business across a myriad parts of the organization. So anyway, hopefully that kind of illustrates how you can, how and where you can begin a big data engagement to, leverage your data to help better run the business.
This to me, it's, I've been sitting here listening to you guys, and I'm sure, people listening are kind of forming some ideas in their head with what data they could use to kind of answer what kinds of questions. And to me, this is pretty incredible, because it's something that just hasn't really been available until recently, it seems like. And it's almost like I've got a genie in a bottle, and I get to rub this thing, and it pops up. And in the past, I've just asked it the three questions that popped into my head, because I only had three to ask. But now I've got this machine that can tell me, what questions you should ask now, which is pretty great, because I don't get to waste my three questions, which is a lot like wasting your three questions now. I mean, a lot of organizations spend 3 years budget answering three questions that they thought were important. They get to the end of the 3 years, they've done a lot of time and a lot of money to answer those questions maybe correctly, and it turns out they weren't the best questions to ask. They weren't bad necessarily, but they just weren't the best questions to ask. Now we're going to open it up to questions to our audience. I want to thank both Dan and Ed for being here today and really contributing to our education series. And we'll open it up for questions. So folks, if you have questions, go ahead and type them into the bottom left corner. There should be a little chat box you can get to, and we'll get to them in a second. But I do want to highlight where you can find these webinars, nogalis.com/education. If you go there, you'll get to access all our past webinars. You don't need to sign in or anything like that. The deck will be available there. The video will be posted there, and any other materials. We are more than welcome to contact us via email or through the site if you have any questions for either Dan, Ed, or myself. And then there's also a suggestion box for any requests that you have for future topics to discuss. So we're going to cut to Q&A now, and let me go ahead. And I know there's a couple of questions already. So let's see here. So Bruce is asking, what tools are you using to support the process?
Yeah, so that's a very good question. So there is no like single way forward here. A lot of times it's a combination of leveraging some of the technology and software tools that are already incumbent within an organization, and other times it's combining that with open source and other tools that are bespoke for certain aspects of leveraging big data. Now, you kind of got to break it down into a couple different facets. So there's, from a data engineering standpoint, who data engineers are really kind of responsible for, aggregating information and making it available to be analyzed. And then there's data scientists and analysts that are actually looking at the information and then, trying to draw insights from it. So we know that there's probably about 150 or 200 different types of tools that are in the marketplace. And maybe it's a little selfish plug for you, Dan. Why don't we just talk specifically about a couple of the tools that you're acquainted with?
Yeah, and it's like Ed is saying, that the world is full of these tools, and there's more coming every day. But the ones that I've used successfully, kind of starting from ingest and store all the way to like insights and monetize. So I look a lot at AWS has some really nice cloud-based offerings. You can sort of create big data storage very cheaply, very quickly. There is kind of a standard established around Apache Spark as the language or the code sort of solution for ingesting and it's called ETL, like the movement of data from one source into kind of a cloud-based repository. So AWS offers a service called Glue, which is a kind of a way to manage all of that ETL, that kind of movement of data pipelines. So that's another great tool to kind of look at. Once you're kind of settled on how to store and kind of, create repositories for the data, then you start to think about visualizing, right? And so my preferred tool is really Tableau. Just a quick little plug there. Tableau just kind of cut their prices in a big way, actually. So they're now kind of competitive with the other big player in the space, which is Microsoft Power BI. And so it's, some really great offerings at an amazing value for the consumer. But the essential point is like you need a way to kind of surface and visualize and interact with that data. And that's where you begin to get into the position to do the type of stuff we're talking about, machine learning and data science. When you're in that sort of tool mindset, as Ed mentioned, open source really has a lot of the answers. So I use Python coding. The other opportunity is R Studio, which is kind of like another more stats-based kind of platform, but they've really become more or less synonymous. And so, depending on the kind of analysis or model you're trying to build, there's libraries upon libraries in Python that you can use to really kind of code the stuff up and make it sort of do what you want to do. So, I think that's a little bit of a
it gives you some more options.
The ones that I like.
There's tools like Blue Talent and Blue Data and Global IDs that do things around policy management and data indexing and tagging. Obviously, if you're having a data lake to store massive amounts of data, you need some sort of distribution, and Hadoop is typically distributed either through Cloudera or Hortonworks or Pivotal. And the the abstraction tools that are being leveraged, like, some that Dan mentioned, are kind of also dependent upon whether or not we're talking about massive amounts of data or data that needs to be analyzed in real time. So, whether it's like, Spark or Kafka or Hive and Mahout and, Madlib, there's a lot of different tools across that supply chain of data that are in vogue. And some of it's, again, dependent upon the data that you're trying to analyze, how quickly and how complex that data is to analyze, and then what you're doing with the analysis once you've uncovered the invisible data opportunities. So hopefully, Bruce, that gives you a couple more thoughts around that.
One of the other questions that we had was around, we have a lot of healthcare discussion here today. Do you have anything in other industries that you can kind of name as an example, education, for example?
Yeah. So like within education, we had a really amazing study that we did where essentially this school district down in McAllen, Texas, just north of the Mexican border, was really struggling with a 50% graduation rate and teachers like being stuck in this small podunk town, wanting to get the heck out of there and move to more lucrative, markets where they get paid more and, have a bigger metropolitan area to live. And so we looked at, believe it or not, like Zillow data, and we looked at some of the enrollment data, and we looked at social media, and we were able to actually surmise that student performance a lot of times was dependent on some demographic information and not necessarily, that the curriculum was not right. And so we were using binary ways to assess teachers, and we were not really hitting the problem head on with what was impacting student performance. Take, for example, you've got a kid that gets a B on the first test in math, and you get another kid that gets a B on the first test in math. What is the likelihood that both of those students are going to have a B at the end of the semester? And it was the answer is, well, it depends upon the home environment. It depends upon how active that kid is in other sports and other social networks. It depends upon whether they're a firstborn kid, an only child, a latchkey kid, have two parents at home helping with homework, or has a single mom, and no one's home helping.
A lot of societal factors.
Right. So when we started looking at some of that other demographical information, we realized that one kid wasn't at risk. They just had a soccer tournament the night before and had an overnight play date, according to Facebook, and that kid just was tired and didn't do well on that test. Not a problem. The other kid, was a latchkey kid, had a single mom and, no help at home to ever get his homework done. That's the one that probably needs some counseling intervention so that kid doesn't fail. So as soon as we were able to kind of understand where the opportunity areas were, we were able to provide support accordingly. Another thing that was kind of cool is that the teachers all had their own way and style of teaching. And there was no way for them to kind of deal in the normal curriculum with how to affect change in the classroom. You've got bullies in classrooms, you've got kids that are shy. And what these teachers did is we created a portal, like a little Netflix for teacher, where by subject, we could actually have a teacher who might have been, say, really good with dealing with exuberant or ADHD kids in the classroom that were disruptive, and how they rechanneled and redirected them so that they would be patient and a little bit more focused in class. Whereas another teacher might be really good at getting a shy kid up in front of the classroom to speak in front of the class. And they were able to share these videos and post them. And a teacher could come in the morning, pick a category, and watch a video. And that caused themselves to be able to empower and enable these tricks of the trade with other teachers. And it didn't have anything to do with changing the core curriculum that was required of them. And at the end of the day, the graduation rate went up to 100%, and those teachers then were, inspired to stay. And so the tenure, started to heal over time, and they no longer had an attrition problem. So, just
so
another
you
example.
went from a 50% graduation rate to 100% graduation rate.
Yeah.
That's just incredible. And you know what? The other thing that kind of really occurs to me, and I know we're going over here, but I could talk to you guys for forever about this topic, because I think it's in my 20 plus years in the IT industry, it's the first time in a long time that I've seen something happen that has been transformative, right? I mean, we've been doing really the same thing for 20 years, it feels like. And this is kind of this era of transformation that I really like. But one thing you mentioned that I really kind of wanted to highlight is, you took data that the customer had, but you also took data that was just widely available. It's just like Zillow data is just sitting there, weather data, population data, the census data, all the stuff in the county and the cities and the governments that are sitting around, and just data from the internet. You can just keep piling it on top until some pattern shows itself that there's no way you could have known about. So I don't think, from a customer standpoint, I don't think you need to be like shy about, oh, I don't know if we have enough data for this. But like, I think it's, the possibilities are kind of endless as to how much data you can overlap from within the organization. And it isn't just data from like Lawson. You could pull it from all of the different sources you've got data.
But if you've got access to Lawson data and you couple it with data from other external and publicly available sources, now you can enrich and make that Lawson data more valuable.
Absolutely. No, I love it. Hey, thank you guys so much for joining us today. I think that was definitely an educational experience for me, and I hope for our attendees as well. For those of you attending, if you have any questions, please feel free to go to our site and use the contact us form, or you can email me directly, tan@nogalis.com, and I'll share those questions with Dan and Ed. And please keep an eye out for our next webinar and sign up for our newsletter. Thanks again. Thank you, guys.
Thank you. It was great being here.
Wonderful.